Here are the solutions to the exercises in Chapter 16. This is dice.c to simulate the rolling of that dice that we talked about. Okay, let's go and have a look at the code. Please enter the number of rolls that you want, and we'll do a little seeding of the random number generator there. Now, don't worry about this, I'll explain it in a second. It's not using macro stuff. This is essentially the code that we do. We do a little for loop for the number of rolls that they asked for. We get the random number from the random number generator. We cause it to be modulo sides. So this is what we're actually doing here. Number equals number modulo sides. So if sides is 6, that will give us a number in the range 0 to 5. Remember that modulo arithmetic? Any number modulo 6 has to be a number in the range 0 to 5. Has to be. That's the trick. That's the clever trick. How many of you out there thought you had to divide by whatever? Yeah, dividing it would not give it to you. So, anyway, add 1 to that to get a number in the range 1 to 6, and then do that. Now, what I thought I would do is I'd write a little macro to do that. Remember macros from the preprocessor chapter? So I wrote a little macro, and it almost looks like a function. Macros always almost look like functions. So you specify the number, and you specify the range that you want it to be in, and it will treat it as 1 to that number. So if you specified a 6 here, that'll be 1 to 6. So this might be 28,216, and this might be 6. So it'll convert that number into a number in the range 1 to 6. And it does that by taking the number, notice the clever use of brackets there, modulo 6, and then add 1. So you can do it either with the macro or without the macro. When you use the macro, this is all you have to do. You don't have to have a variable called number, and you don't have to do these 3 steps. You just can do them all inside the printf, all in one go, just like that. There's the random number, and we're saying modulo 6 essentially. So you've got 2 ways of doing it. So if you want to test it's working, you can either hash define not using macro, or you can not hash define not using macro, and it will get one version or the other. So that's it. Let's look now at that huge program which has become our CD database. Okay, I've added one file to our project, and that is file.c. The rest are still there, but they've changed somewhat. The changes are extensive. It's going to take me a while to describe them. What I think I'll do is I'll start with main and show you how the great project looks from a top-down standpoint, and then we'll go and have a look at some of the smaller functions, like the ones created in file.c and so on. Some of them don't change at all. Output didn't change at all. The only changes I made to input were to revert back to using arrays for the title and artist names. So there's very few changes there. I probably don't even need to show you those. But main's got a great number of changes in it, and we've got a new one called file.c. So let's look at main first. Okay, here we are in main. Let's go right to the end and have a look at the actual main program itself. At exit, goodbye. Okay, well let's quickly go and find goodbye. There's goodbye. It calls something called reset everything. We'll find out what reset everything is in a moment. And then it says press enter to exit the program. Notice it is a static void. Now, notice the use of main here. Main takes 2 parameters, argc and argv. And I've said if argv is greater than 1, remember that the first one, is the name of the program, so it's got to be greater than 1, then process the first string, or the first parameter on the command line, which is actually the second string in the array of strings, the first one being the name of the program. And that does a general open. We'll have a look at what general open is in a moment, but you can imagine that it's going to be a program that opens up a file and reads some CDs out of it. Then we say welcome to the CD database. We only do that once, and then we go into an infinite loop displaying the menu. So it's going to display the menu, then it's going to read a choice from them, and then it's going to display the menu again, and it's going to read another choice and display the menu again over and over and over and over again until they press option number 9, which will be to quit. So let's look at the display menu program next, which is here. Display the menu. Tell them how many records there are that we've currently read in. If we've started from scratch, there'll be 0. And we've got a global variable that we're going to call fname, which is going to be the name of the file. Let's go and have a look at that. We've got 4 global variables here. Now I said I don't like global variables very much, but static globals aren't too bad because their use is restricted to just this one file. So we've got to have the name of the file that we're currently processing, the file that we've either just opened or the file that we've just saved to. We're going to have the CDs. We're going to have a dynamically allocated array of CDs, which gets initialized to null because all statics get initialized to 0, and null is just another fancy way of saying 0. Then we've got the count of those, and that again is initialized to 0. And then we've got a boolean. Have any changes been made? Now that we're going to use that to determine whether we need to say things like, are you sure you want to discard your changes? We have to obviously know whether there have been any changes. So I'll just have a simple 1 if there have been changes and 0 if there have not been changes. Okay, let's go back down to display. Okay, so if the length of the file name is 0, in other words we have not entered a file name, then we can just simply say there isn't a file name, otherwise display it, and then display the menu. And this is what I asked you to make your menu look like. Then I can take advantage of my little function called readInt. Remember old readInt? Comes in handy sometimes. And then that's going to give us an integer, which is hopefully going to be a number in the value of 1 to 9. And then I can switch on that. This is inside a loop because they may not enter a valid one. In other words, if they don't enter 1 to 9, then I can say invalid selection, please try again. They get to enter another number, and we go back around the loop and try again. And if they entered anything else, then we'll be in here. We'll go file new, or file open, or file save, or file save as, or file append, or edit add, which creates a new record, or display one, or display all of them, or quit. In other words, it's pretty straightforward. We're just going to call whatever function corresponds to what they chose. And then we'll press enter to continue after each function has completed. And that's all there is to it. That's display menu. So let's go and look at each one of those. Quit. Quit says, are you sure? There's a little question. I've written myself a function called are you sure, which will return a 1 or a 0, depending on whether they said yes or no. If they say yes, you'll get back a 1. So if they are sure, then we can exit 0. Now, the are you sure function is here. It says if there's no changes, we don't need to ask the question. We don't need to ask them if they're sure. Recall that if you're in Notepad and you've saved your changes and then you try and exit Notepad, it doesn't ask you if you're sure, you just exit. But if you've made changes and you haven't saved them, then it asks you, are you sure that you want to discard your changes? Or something to that effect. So you get a question like that. There's my little yes-no function again, which is now coming in quite handy, and I can say yes or no to that question. So that's what are you sure does. So back down to quit. So that's all quit needs to do. And obviously some @exit processing will occur when they do an exit. Now, let's go and look at the rest of them. Let's go and find the file new option. That'll be up the top here somewhere. Scrolling. Okay, there it is. File new. Again, we want to make sure that we ask them the question, are you sure you want to do a file new? Because Notepad will do that. If you've typed in some words into Notepad and then you go file new, Notepad will say, are you sure you want to discard your changes? And if you are sure, then we'll reset everything. And reset everything means discard all our changes. Which means we've got a great big array of CDs, which is dynamically allocated. We have to free it. So let's have a look at that. Here's reset everything. So if there were some CDs, in other words, if we have allocated some CDs, in other words, the pointer to CDs is not null, then free them and reset it back to null. Notice that freeing CDs does not set CDs back to null. You've got to do that yourself. Set the count back to 0, say there are no changes, and clear the file name because we're doing a file new or something similar. Remember that right down the end of the program, in goodbye, we reset everything as well. Specifically, I want to free the array of CDs. I know that we can get away with it if we're exiting the program. We don't actually have to free anything because the operating system will do it for us, but I still like to get into the habit of freeing everything that I allocate manually. It's just a good habit to be in. So we reset everything exactly the same way at the end of the program. Let's go back to File New. Okay, so File New is a pretty simple thing. We just discard all the changes and reset everything back to its initial state. What about File Open, File Save? Let's have a look at those. Let's have a look at File Open first. Okay, here's File Open. We're going to set aside some space for a new file name, and notice that we've got a hash define that tells us how big the size of a file name is going to be. Again, we want to prompt them if they're sure. We want to say, look, you haven't saved the changes. Now, if they have saved the changes, they won't get the question. But if they have not saved their changes, then they will get the question, are you sure? And if they say no, then we simply return because there's nothing else for us to do here. Otherwise, we ask them to enter the name of the new file that they want to open. Notice that that file may not exist, so we can't read that directly into fname. We have a variable called fname which is storing the name of our file, but if there was an error and we couldn't open the new file that they specified, then we still want to keep our existing file name. So then we call this thing called general open again. Remember, we called general open before when we were using the command line parameters, the argv's and argc's. So let's go and look at general open now. General open is right here. General open basically says open this file and read in some CDs from it. So we'll allocate the CDs here. We'll have a new pointer for some new CDs and a new count just in case it fails. So we'll read them in now from the file. Now this function here is in file.c. So I'll go and have a look at that later, but take it as read for the moment that it will open up this file, and if there are some CDs in it, or even if there aren't, it will pass them back here as a pointer. It will dynamically allocate space for those CDs, and it will set new count to be however many CDs there were in there. So we need to pass in the address of new count in such that OpenFile can actually change it. And OpenFile will return -1. Well, actually, sorry, it will set new count to be -1 if there was an error opening the file. In which point we can do a p error, could not open the file, and we will return. So now if that is the case, if we could not open the file, then our original list of CDs has not changed because we pointed this set of CDs at a new variable called new CDs. So CDs now represents CDs from an actual file. Then it's time for the new array to become our current array. We have to start using the array from the new file. So we reset everything, which means discard all the existing CDs that we've got if there are any. And notice that we will already have done the question, are you sure? Because that was down here in file open. There's the are you sure? So we know that they want to do that. So we reset everything, and then we simply set the 3 new globals. Reset everything will also set changes equal back to 0, so we don't have to set that manually ourselves. And then we put out a little message saying that we successfully read the file. Okay, so that's file open. All we really need to do at some stage is go and have a look at open file. But we won't look at that now. We'll look at everything in that file.c in one hit. So that's file open. Now there's a general save, but I'll show you how general save is used. We've got file save. Remember, this is menu option number 3, and then we've got menu option number 4, which is a save as, and then we've got file append, which is menu option number 5, and they all do a general save. 1, 2, 3. That's all they do. General save takes 2 parameters. It takes 2 booleans. One is, do they want to do an append? And the second is, do they want to do a save as? Both of those will be true or false, 1 or 0. And they're mutually exclusive. You can't be doing an append and a save as at the same time. So the first one, this is just a regular save. So we're not appending, and we are doing a save as only if the current file name is empty. Remember? Think about that in Notepad. In Notepad, if you do file save and you haven't specified a file name before, then it will prompt you for a file name. In other words, it'll just do a save as. So we're going to do a save as if they haven't yet specified a file name. And then the regular file, the save as is we're not appending, but we are doing a save as, and then append is we are doing a append and we're not doing a save as. Okay, so we're reusing code here. We've got one function called general save, which is going to do every type of save we could ever want to do, and we're just going to call it 3 different ways. I like doing it this way because we reuse code. I know it makes it kind of complex because we've got lots of ones and zeros and flags and so forth, but all our opening and closing is done in the one place. It's all done here. All our prompting for new file names and everything, it's all done in here. Now, if we're doing an append or we're doing a save as, then we need to prompt them for the name of the file. And we'll read that into this new file name here. If we're just doing a regular save, so we're not doing either of those two, we're just doing a regular save, then the file that we're going to use is the current file. Now, we've got a quite a complicated little thing here. If we are doing a save as, in other words, if we're trying to write out to an existing file and that file exists, and this function I've written myself and that's in file.c as well, we'll have a look at that later. So if we're doing a save as, in other words, they've just specified the file name and the file name that they've just specified exists, then we prompt them for confirmation of that. We say the file exists, are you sure you want to overwrite it? And if they say no to that, then we return. So we do these 3 things in sequence. I don't know if you know this, it's probably a good time to mention it now, but if save as is false, then it doesn't even go and do these things. And if file exist is false, then it doesn't go and do this. It's a very handy thing that you can take advantage of with this the ampersands. It means if this is false, if the first condition is false and you're using double ampersands, then you don't even try the second condition. That is what the compiler does. You can guarantee that, you can rely on that, and you can code around it, which is exactly what I've done. So if they're not doing a save as, then these 2 questions won't even happen. It won't test to see if the file exists, and that won't ask the question, hey, the file exists, are you sure you want to overwrite it? So, we have successfully entered the name of a file if we need to, or we've got the name of the file from here. We've checked to make sure that we're allowed to overwrite it if the file is already there. Now we simply save the file. And this saving file, that is in file.c, and I'll show you that when we get to file.c. Suffices to say you pass it a file name, you pass it an array of CDs and a count of those CDs, and tell it whether you want to append or not, and it will go off and try and do it. And if we succeeded, tell them about it, set the changes back to 0. Changes have been saved, so we don't need to worry anymore. And if they were doing a save as, then make sure that we copy that new name back into the main F name for the entire program. Okay, the rest of the program is pretty much as before. We've got the edit add. Now you've seen all this before. Please enter the details of CD. Actually, there is one slightly complex thing that we have to do, is every time we read the details of a new CD, we have to reallocate space for our array of CDs. So in other words, if you've got 10 CDs in your dynamically allocated array, and then they decide that they want to create an 11th one, then you have to do a realloc. Not a malloc, not a calloc, but a realloc. Remember that? And I've done all my reallocating in here. This is a little function that I've written. You'll find this in utils.c, which is going to reallocate all the space for CDs. Anyway, we'll see that later. So I increase the size of my array by 1. That's what the 1 there is there for. Increase the size of my array, copy the CD that they've just read in, that's this one, into the last spot, and then increase my count by 1. And yes, now changes have been made. So we obviously want to make sure we ask the "Are you sure?" question before they quit or whatever. Display 1. Obviously, if there's nothing to display, tell them there's nothing to display. If not, ask them for a number. We can use our clever little function called readIn for that. Please enter the number of the CD you wish to read and check that it's in the right range. It has to be between 1 and count inclusive, and if it's not, then just tell them an error message and go around and ask again, and then print out the details of that CD. To display them all, we just make sure that there are some in the first place and just print them all out, and that's all there is to it. Press enter between the viewing of each one. Now you've seen all that stuff before. And quit we've already had a look at. So that is main.c. We'll have a look now at file.c, where we do all our file operations. Here's file.c. To test whether a file exists, this is our little file exists program, which returns a 1 if it exists and a 0 if it doesn't. We can try and open it for reading, and if that failed, then we say, right, the file does not exist. And if it succeeded, then we close it and return 1. Now there is actually a nicer way of doing it. There is actually a library function called stat to do that, and you can look up stat if you want to, but if you don't know anything about stat, then this is not a bad way of doing it. You're just going to open the file for reading and close it again immediately. Okay, so we've got now a function called save file. You will get a file name. This will take a file name and a bunch of CDs, an array of CDs, and this is how many CDs there are, and this is whether we want to append or not append. And if we're not appending, then we're just writing to the file. It's a pretty simple function. Try and open the file. There's the use of our conditional operator. If append is set to true, then use that append a binary file, otherwise use just a regular write binary. And if the file pointer was null, then return -1. We failed. Notice that erno will be set in this particular instance, because the fopen will fail, and erno always gets set if fopen fails. Write out all the records, so we do an fwrite, and we pass in the CDs, and the size of one CD, notice that's the first element of the CD, so we pass out the size of one CD and how many there are, and this is the file pointer that we're going to write to. Now that hopefully will equal count, because we're saying please write count CDs. So if it doesn't equal count, then our little return value is going to be set to 0. Otherwise it's going to be set to -1. 0 means no error, -1 means error, because that's what I've defined here. -1 if there's any error, or 0 for success. Finally, opening the file is equally simple. This will open this particular file and try and read some CDs from it. If there are any CDs in it, it will allocate space and read those CDs in one at a time. And when it's finished, it will set this number to represent how many there were and return a pointer to the memory area that it allocated. And if there was an error, it will set num to -1. So that's how you'll know there was an error, and you'll get back a value of null. Now, so we open the file, and if it failed, then we set num to -1 and return null, as you'd expect. Now, we successfully opened the file, so set our counter to 0. While we can continue to read from the file, in other words, we've got a little space set aside for one CD there. We've got a variable just called CD, and we'll try and read that much data into it. And so we say that's how big it is. We want one of them, and while we continue to get one of them, that means we haven't reached the end of the file yet. So, just as I did before, increase the size of the array. In other words, do a realloc on the array to increase its size. Structure copy that CD that we just read in from the file onto the end of that array, and increase the array size by 1. Notice where I have to put the brackets here. I'm trying to just increment the variable called num, but num is a pointer, so I have to obviously take the contents of that pointer. Now if I didn't put the brackets in there, it would do this. It would increment the pointer, whatever that means, and then take the contents of that. But what would it do with those contents? Well, nothing. So I don't expect you to know why. Just know that that is a precedence rule in C, that the plus plus operator has a higher precedence than the star operator. It's one of the things I don't like about C. So to fix that, you've got to do that. Anyway, close the file pointer, return new CDs. Num will be automatically set because we're incrementing it as we go. Okay, so hopefully somewhere else we'll actually free that up. And if you think about the logic of what I showed you in main.c, you'll see that it does actually get freed at the appropriate times. Finally, we'll have a look in utils.c, because there's one thing we need to look at in utils.c, and that's how are we increasing the size of the array of CDs. Let's have a look at that. Okay, here's utils.c. Here's increase array. Well, I could spell it right in the comment. There we go. So you pass in the old array and then the old count and how much you want to increase it by. Now these two could be empty. In other words, old array could be null and old count could be 0. And if one of them, if old array is null, then we assume that count is 0 and vice versa. So that's a requirement for using this function. If you're going to pass in null in old array, then you have to pass in 0 in old count and vice versa. Then we set a new array. So if there wasn't anything in the array before, then we just do a regular malloc. If there was something in the array before, then we do a realloc. Okay, fair enough. We had a look at malloc and realloc, so you should know what they are and how they work. And if the answer we get back from that is null, then we say the program is out of memory and we exit. And then we simply return the new array. So that's all there is to it. Okay, let's see if the program works. Compile. Now that just compiled every single file in my project, and I think there's 5 of them plus a header file, so we got no errors out of any of that, and we'll run it. Let's see what it does. Welcome to the CD database. There are currently 0 records in the system and no current file name. Okay, so let's create a new record. Okay, so it's option number 6, and we'll call this title 1, artist 2, number of tracks 3, it's an album, retail price $6, press enter. Now we have 1 record in the system and no current file name. So let's save that out to a file. Let's save the list, which is option number 3, and we'll call that cd.dat. Got to call it something. List saved successfully, 1 record. Okay, let's try and save again, only this time, okay, well that's good. It saved the list a second time. Let's do a save as. So we need option number 4. Please enter the name of the file. Let's give it a silly name, a name that we know doesn't exist, j:/xyz.dat. Cannot save the list, no such file or directory. Okay, fair enough. So theoretically we should still be called cd.dat, and we are. It didn't adopt the erroneous name. Okay, how about we close that. Let's quit that now. Press enter to exit the program. Run it again and read in from that file that we just saved. cd.dat. Successfully read file, 1 new record. Press enter. Now we're called cd.dat and we have 1 record in the system. Okay, very nice. So let's now add a new CD. So we'll do option 6, and this can be okay, so now we have 2 records in the system, and let's try and quit now. 9. Are you sure you want to discard all records? Oh, it didn't ask us that before because we had saved our changes before, so that's good. So I won't quit. Instead I'll try and create a new list. 1. Are you sure you want to discard all records? Again because we haven't saved. I'll say no. Instead, I will simply save directly back to the file. Let's save successfully 2 records. So now the file contains 2 records. So now, if I create a new list, 1, it just simply does it. Doesn't complain about it. And now there are no records in the system, and there is no current file name, but the file cd.dat does contain the 2 CDs that we just saved. Okay, so I could go through all the other options, but I'm sure that they work because I tested them extensively before I completed this program, and you will be able to hopefully compile my program and test it yourself if you don't believe me. I welcome all your bug reports. If you can find a bug in the program, I'm more than happy to give you a gold star.